Hello guys, welcome back to my YouTube channel. We're still under the pumps. This fluid N6. I want us today to discuss the effect of friction on indicator diagram. The effect of friction on the indicator diagram, right? Let us see the effect of friction. Right. Remember the friction H F is equal to 4F L V squared over 2G dm. Remember the friction in the pipe, it will be there, that will oppose the water from the suction pipe to the delivered pipe. There must be some sort of a friction there. The friction will consider the friction at the start of the suction, at the start of the suction stroke, and the friction at the end of the delivery stroke. So I want us to know that, you must know that this is a friction, right? What about, I want us to discuss about this thing of V. What about V? We know that V is given by, will be area over area multiplied by WR sine theta, right? And then this theta is equal to 0 at the beginning. Right, at the beginning, theta is equal to, must be equal to 0 at the beginning. At the beginning stroke, at the beginning of stroke, at the beginning stroke, right? Theta is equal, but theta is equal to 90 degrees at the middle, yeah, or at the mid, you can say at the mid stroke. Then theta is equal to 180 degrees at the end stroke, or at the stroke end, at the end of stroke. Theta must be equal to that. Remember, if we have a diagram, our diagram is like this, right? Here we have theta. Remember, here is theta, here is pressure, this side, right? This pressure here will be what, 90 degrees, it will be 180 degrees. Here we have atmosphere, or HAT. This is absolute 0. You know, this theta here at the start, remember at the start, okay, this one start at the beginning, or we can say beginning. This is where it's a beginning. This one, it's a mid. This one, it's an end. Stroke. Right. Hope you understand this. Right. So, remember, since we know this, then that means HF, you will replace it with, now we have squared here, you can say square, then you're supposed to square even this one because it is squared here. You'll say HF must be equal to 4FL over 2G. Do you multiply this? But V is what? Must be A over A multiplied by WR sine theta. You square this, right? You square this. Now I want you to check something. When you have punch your calculator, I want us now to investigate when H of S, or when friction will, when, okay, want to say when theta, I want to check when theta is equal to 0 degrees, HF will be what? HF will get, what will be HF? We just check what will be the value of HF, or what will the sign, or what will determine. Okay, what I'm trying to say is this. Let me punch calculate. Remember, there's a sign. Sign 0 is 0. You see, if we put 0 here, this will be 0. When you multiply by 0, this thing will be what? Will be 0. That means when theta is 0, this whole thing will become what? Will become 0. But when theta, let's check, when theta is equal to 90 degrees, HF will be what? Let's check that HF will be what? Right, sine 90. It's what? It's 1. Then that means if it's 1, remember when it's 0, when it's 0, this whole part will be 0. But when it is 1, we'll have something. Our HF will be 0. When theta is equal to 0, our HF will be equal to 0. When theta is equal to 90, our HF will be equal to 4FL over 2DG into area over multiplied by WR squared. There will be no longer what sign, because now sign will be replaced by 1, right? Since there will be sign is like 1. When you multiply by 1, the sign will fade away. There will be no longer sign. What about when theta is equal to 180? Let's check. Punch sine 180. Sine 180, you get 0. So if this is equal to 0, when you multiply this will be what? Will be equal to 0. That means HF also will be equal to what? To 0. Right. So this is what it is. Will be equal to 0. As you can see, when it's 9, it will be equal to 0. Because remember, if you have HF, let's say 4FL over 2G, D, area over area, WR sine. Let's start, put 0 here, will be sine 0, right? Sine 0 is what? Is 0 on your calculator. That means this will be 4FL over 2GT multiplied by, this is 0. When you multiply by 0, you'll have what is 0. Then that means when theta is equal to 0, when theta is equal to 0 degrees, also our FFH will be equal to 0, right? Friction will be equal to 0 there. So I hope you understand that. So now let us replace here. Again, let us prove it. Let us replace this with what? With 90. When you replace with 90, this will be 4FL over 2GT into area A WR. This is what is the same as 1. This will multiply by 1. Then when you multiply by 1, it will be like this only. Right, that means we'll have this. When is equal to 180, we'll have 0. When you replace 180 here, then our h of x will be 0. When it's 180, h of x will be equal to 0, our h of x. When it is 180 at a degrees, you understand? Hope you understand this. So since you have seen that this will be equal to 0, you see. So let us try to depict this information, to draw, as we know that our diagram is like, right, then here we have the atmosphere, or this is the atmosphere. Here absolute 0, absolute 0. Let's say here, let me start here. I can start here and say 0 degrees, and here 90 degrees here. Then let me say 90 here. There, say 18. You know this is theta. Go to that direction. Here it's pressure. This pressure, right? Here it's 0. I decided to put 0 here, not here. Here, if it is 0, you know we'll start by writing what? Rectangle shape like this. Have a rectangle shape like this. Until where it is 18. There until here. So on the suction side, you go up till when you get somewhere, you return back. Remember, this is the suction, this is the delivery. We know that we'll have here 19. From here, straw, right? Same thing applies here at the top. From there, right? What it here, we know this will be this distance. Here is HAS, right? Then this distance from here till there is H suction. This distance from there till there is H delivery. This one here, you know, that will be HA delivery, right? Now we have this. Now let us remember this is it is a diagram of accelerating when affecting both sides, right? Now let us check. Now let us include the friction. How does the effect of friction will affect? How does the friction will affect this diagram? Now remember, when theta here is theta. When theta is 0 degrees, we come when theta is 0 degrees here, HF will be equal to what? To 0. That means we'll have a dot here. When theta is equal to 0, HF will be equal to what? To 0. Right. Now, what about when this is equal to 90? We'll have, you see, a parabolic. We'll have this. That means we'll have a value, because we don't know this value, but because there is a squared, this is what is parabolic. You see, it is parabolic. That means somewhere here we have what? The maximum. Yeah, somewhere here must have some value here. What about when theta is 1/8? HF is 0. When it's 1/8, HF is what? Is 0. Right. When you draw something here, remember the shape. Remember here, where it is 9, will have the maximum. When theta is equal to 90 degrees, we'll have maximum. HF will be maximum. We'll have HF will be maximum. We'll have a maximum. Then here it will be our 10 and draw. Let us try and draw this parabolic shape like that. Reach the maximum. See, this is a maximum. HF here. You see, this is HF. We'll have HF there. Here until here. What is this? Is H. It's HFX at the suction. I get the suction HFS at the suction side, because this is the suction pipe. Also, we know here we'll have a dot 0. Same thing, when it's 90 here, we'll have a maximum somewhere here. Then we can try and have something shaped like parabolic. Also here we have something like, right, something of this nature from here also until there. We'll have HFD, and then it's a max Y. HFF is maximum. So at the 90 degrees, when it is 90 degrees is when we'll have maximum is where have our friction there. Frictional head will be at the maximum. We'll have H max there. This is what it is. So thank you guys. Stay tuned and do not forget to subscribe. Yes, I'll be posting some new videos under this topic. Sharp.